until Voyager conducted its tour, its Homeric odyssey across the outer solar system.
The most distant human-made object, NASA's Voyager 1 spacecraft, is in interstellar space.
The cosmos has always been an infinite playground of mysteries and surprises that have left us wanting more. From breathtaking views of distant galaxies to astonishing revelations about the origins of the cosmos, powerful telescopes have unlocked countless mysteries. Thanks to historic collaborations between the commercial sector and foreign nations, scientists have achieved remarkable feats in space exploration, culminating in the launch of the world's most potent space telescope, the JWST. However, amidst all these monumental achievements, a perplexing encounter took place when the Voyager 1 probe ventured into interstellar space and made contact with an enigmatic force. What obstacle did Voyager 1 encounter on its journey into the unknown? What implications did this encounter have on our perception of the universe? And what does NASA have to say about it? Join us in today's video as we delve into the captivating story of Voyager 1 and its rendezvous with the unknown. Launched in a blaze of anticipation from Cape Canaveral, Florida in the summer of 1977, the twin spacecraft Voyager 1 and Voyager 2 embarked on an epic journey to explore the wonders of our solar system. Originally planned for a 5-year mission to study Jupiter and Saturn up close, these intrepid space probes surpassed all expectations. As the mission progressed, the Voyager team at the Jet Propulsion Laboratory in Pasadena, California, couldn't resist the allure of the outermost giant planets Uranus and Neptune, and successfully reprogrammed the spacecraft to extend their mission. What was meant to be a 2-planet exploration turned into a 4-planet odyssey spanning decades. The Voyagers became legendary, venturing across the solar system, uncovering mysteries of 48 moons, rings, and magnetic fields, and rewriting the very textbooks of astronomy. Now, after nearly 4 decades of pioneering exploration, the Voyagers continue to astound us with revelations about the origin and evolution of our solar system's planets, posing intriguing new questions that challenge our understanding of the cosmos. Voyager 1 has now ventured further than any other artificial object in space, a staggering 14.7 billion miles away from Earth. It achieved another unprecedented milestone by becoming the first man-made object to explore the mysterious realm of interstellar space, that vast expanse between stars within a galaxy. When it was 122 astronomical units away from the Sun, scientists confirmed that Voyager 1 had crossed the threshold of the heliosphere, where the solar wind, a stream of charged particles from the Sun, dominates, and entered the uncharted territory of interstellar space. All thanks to a crucial clue from particle density. "Nobody ever expected the Voyagers to leave the interstellar medium," exclaimed an astronomer from Boston University who heads a center called SHIELD that's delving into Voyager data to uncover more about the heliosphere. The twin spacecraft's findings about the heliosphere, the magnetic bubble that envelops our home planet, could potentially shape our understanding of life on Earth. Surprisingly, at those mind-boggling distances, the density of particles was found to be 10 times higher than that of the solar wind, a discovery also confirmed by Voyager 2 when it entered interstellar space on November 5, 2018. While entering interstellar space was relatively straightforward for the probes, navigating the heliopause, the twilight zone between the heliosphere and interstellar space, proved to be a complex and intriguing challenge. It took each spacecraft several months to pass through this enigmatic region, during which they diligently transmitted invaluable information about the peaks and valleys of plasma density, unraveling the secrets of the cosmos in the process. The mind-bending data from Voyager 1 and 2 on the magnetic fields at the heliopause has left scientists scratching their heads in bewilderment. According to theories, when the magnetic field from the Sun meets that from the vastness of space, there should have been a noticeable change, with the galactic magnetic field expected to tilt towards the solar magnetic field. But to everyone's surprise, the intrepid Voyagers detected no such shift in direction. Now that Voyager 1 has ventured a whopping 40 astronomical units beyond the heliopause, researchers have a front row seat to study the interstellar medium like never before. And what they're discovering is shattering previous assumptions, as it turns out the heliosphere, that protective bubble of the Sun's influence, wields a far greater impact than imagined. The Voyager probe's measurements of the interstellar medium reveal a tumultuous dance between the Sun and its surroundings, with the Sun's agitations and influences rippling through the cosmic expanse. Scientists are left scratching their heads trying to decipher the puzzling phenomenon. The data shows that galactic cosmic rays behave in unexpected ways, depending on whether they are aligned parallel or perpendicular to the Sun's magnetic field. And it's the Sun's eruptions called coronal mass ejections, CMEs, that are extending their magnetic perturbances far into the interstellar medium, potentially explaining the perplexing findings. This has forced scientists to re-evaluate their understanding of how cosmic rays can reach our home planet, Earth. As the silent ambassadors, Voyager 1 and 2 continue their intrepid journey, soon to enter the pure interstellar medium. They are unlikely to encounter a cosmic cocktail from other stars as the Sun's influence diminishes and turbulence subsides, giving us unprecedented insights into the mysteries of the cosmos. However, with the probes approaching the end of their operational lifespan and their power supplies dwindling, the last transmission from these trailblazers is expected to be in the 2030s at best. But fear not, for recent breakthroughs in technology, including the cutting-edge James Webb Space Telescope, are revolutionizing our understanding of the universe, allowing astronomers to peer further back in time and unravel the secrets of the cosmos in ways never imagined. In a breathtaking follow-up to the mesmerizing image of Neptune released last year, Webb has now captured a jaw-dropping image of Uranus, the solar system's other icy giant. This captivating new image reveals the planet's stunning rings in all their glory, while also showcasing dazzling features in its atmospheric dance. But what makes this data truly groundbreaking is how Webb's unrivaled sensitivity has unveiled the faintest dusty rings that have remained elusive to all but two other facilities: the iconic Voyager 2 spacecraft during its historic flyby in 1986, and the state-of-the-art Keck Observatory with advanced adaptive optics. As the seventh planet from the Sun, Uranus is a true enigma. With its peculiar tilt of roughly 90 degrees from the plane of its orbit, it spins on its side like no other planet in our solar system. This unique orientation results in extreme seasons, where the poles experience years of unrelenting sunlight followed by years of utter darkness. Fun fact, Uranus takes a whopping 84 years to complete a single orbit around the Sun. At present, it's late spring at Uranus's northern pole, beautifully captured in the image before us. However, the northern summer won't arrive until 2028. In a striking contrast, when Voyager 2 paid a visit to Uranus, it was summer at the southern pole. But now the South Pole has ventured to the dark side of the planet, shrouded in the abyss of space out of our view. The wealth of information captured in this image is simply mind-boggling. Webb's near-infrared camera employed two filters at 1.4 and 3.0 microns to create this mesmerizing composite, showcasing Uranus in a dazzling blue hue. This stunning display of color and detail surpasses Voyager 2's visible wavelength images of Uranus, which revealed a relatively featureless blue-green orb. With the infrared wavelengths and extra sensitivity of Webb, we see more detail, showing how dynamic the atmosphere of Uranus really is. At the pole facing the Sun on the right side of Uranus, there is an area of brightening referred to as a polar cap. This unique feature seems to emerge in the summer and vanish in the fall when the pole enters direct sunlight. The recent data from Webb's telescope will aid scientists in understanding this perplexing phenomenon. The polar cap has an expected enhanced brightening at the center, which was only visible due to the sensitivity and longer wavelengths of Webb's NIRCam. In addition, Webb also captured many of Uranus's 27 moons, with the 6 brightest identified in the wide view image. However, this was only a brief 12-minute exposure image of Uranus using just 2 filters, indicating that this is only the beginning of what Webb can do when observing this mysterious planet. Furthermore, the James Webb Space Telescope has unveiled a captivating alien world shrouded in clouds of silicate grains that bear a striking resemblance to sand. This distant planet's atmosphere is in a constant state of flux, with materials rising, mixing, and shifting during its 22-hour day, causing dramatic changes in brightness unlike anything observed before. Led by the brilliant Brittany Miles from the University of Arizona, the team also made astonishingly clear detections of water, methane, carbon monoxide, and even evidence of carbon dioxide using Webb's groundbreaking data. Dubbed as VHS 1256b, this planet lies about 40 light-years away and has a unique orbit, not around one, but two stars spanning over a staggering 10,000 years. VHS 1256b is located 4 times farther from its stars than Pluto is from our Sun, making it a prime target for Webb, exclaimed Miles. This means the planet's light is not mixed with light from its stars. In the upper layers of its atmosphere, where the silicate clouds swirl, temperatures soar to a scorching 1,500 degrees Fahrenheit, 830 degrees Celsius. These silicate clouds are in a frenzy, with some scientists speculating that the larger particles may resemble searing hot sand grains, while the finer particles might resemble minuscule smoke particles. Unlike more massive brown dwarfs, VHS 1256b has low gravity, allowing its silicate clouds to potentially form and persist in higher layers of its atmosphere, where Webb can observe them. Given its youthful age in astronomical terms, the planet's sky is tumultuous, adding to its intriguing character. But what sets this discovery by Webb apart from the rest? It's unique because, unlike previous studies of planets in the Milky Way that only found one feature at a time, Webb's study uncovered all of the planet's features at once, making it truly distinctive. No other telescope has ever simultaneously revealed as many characteristics of a single object. The planet orbits so far from its star that scientists were able to directly observe it without the need for a coronagraph or transit technique. The two Webb instruments captured a significant portion of the near to mid-infrared light emitted by VHS 1256b, and when the data was plotted on the spectrum, the researchers made astounding discoveries, including signs of silica clouds, water, methane, and carbon monoxide, and even some potential biological markers. Could this imply the existence of life on other planets beyond Earth? It's a question that is undoubtedly on everyone's mind. As VHS 1256b continues to age, scientists estimate that it will eventually cool off and may lose some of its dense cloud covers. For now, however, the planet remains engulfed in its own scorching and hazy spectacle. There is still so much more to learn about VHS 1256b as the team and other researchers delve into Webb's high-resolution infrared data in the months and years to come. We're eager to hear your thoughts on these groundbreaking discoveries. Comment below and let us know what you think.